So we're going to continue now with the last point of Unit 8, electricity, with 8.11, living with electricity. So you go to any socket and you see this on your living room, your bedroom, your kitchen, etc. So you find fuse box or breaker box, and then you find the plug. For example, here we have a kettle or water heater. You can see that on your book, page 194, this example. So what's happening is here, if we have here the fuse box or the breaker box, it gives us the electricity. Okay? Then it's connected to the switch. There is a switch. This switch you have found next to the socket. Then we have a plug. Usually it's fused. So the normal countries, or let me say there's two types of countries that use two different volts. For example, here the countries use 220 volts until 240 volt AC, of course, and other countries they use 110 volt until 130 volt. So here our normal electricity here is 220 volt, and the frequency is 15 hertz. Okay, so the frequency, of course, it's mean how the waves for the AC come and go. And other countries are 60 hertz. So for alternating current is what is the thing, the current that comes and goes. Okay? So how does that work? So for example, we have here this kettle. You turn on the switch. Okay? You plug this and you find the heater will start to heat the water heater. So here's the same. We can take from the fuse box or the breaker box 2 or 3 cables, insulated cables for sure. So the life for hot wire. So the life for hot wire, when you with this kind of screw and you find it sliding. That means, or they call it also fans. So life, hot or cold, let's say. So you won't be confused. So it's connected first of all on fuse, and you're gonna talk about this the fuse. Then connect to the switch. Then this is the two sides of the plug. Then connected both of them to heating element. So what is the fuse? The fuse is thin filament wire that when it's overloaded it will melt. For example, this heater, let's say take 9 ampere or 10 ampere. But what kind of fuse we should put is 13 ampere. So when it's really overloaded, the fuse will cut or will explode. It depends on the heat or what the problem, when they had the problem. For example, the heater had a short, or there's water inside the heater, or there's an old cable or something, and it will connect to each other and make a fire. Okay? So the fuse is what? It has protection. So here if the fuse, something wrong happened with the kettle, it will cut off. Okay? Here the switch, as we say, connected to both with the neutral or the cold. So the electricity comes from what? From the hot and from the cold, from the light and the neutral. So here we give the volt. And then here is usually the computer will make it 0 volt. And connect it to the heating element that it will make it hot for the water. And here we have earth. Earth is connected to the metal cover for the water heater. Why? For example, let's say this cable is cut and it touched this. So the electricity will be all over all over this body. So the body will be electrical. So if you touch it, you will get electric shock. So it's connected to the earth, and the earth will the electricity will directly go to the earth, and the body will be safe. So you won't get electrical shock. So we see we have two types of plugs. One have three, other one have just two. So the three that is most usual here. So if one is for the hot, one is for cold, and one with the air. Usually the top one is for the air, and the second and the third is for the hot and cold. And the other one is have just two metal bars, as you can see here. One for N, or one for hot and one for cold. And you find here is some metal, it's for what? It's for the earth, it's by connecting. You can see this here in page 195. So, now we understand how it's working. So again, the light of the neutrons going to the heating element, then the earth for the body. So light discourse electricity, negative and positive, making the current flow backwards and forwards the circuit. So that means the AC voltage is what is up and down. That's what makes the light current AC. Natural cold wire, this completes the circuit. In many systems, it keeps zero voltage by the electricity supply company. So we see here, it will keep the zero. The switch, we say, turn it off and it turns it on. Why? You see, you notice where is the switch. So when you cut this off or put it on, it won't turn on if you didn't close it. Okay, so you see the switch and you see the small red light, that means it's connected to the lid and the resistor, and it tells you there is electricity washing. The fuse we explained, that's what it's for protection and it's made at certain point. So we say, for example, of this heater, we should put 13 ampere fuse until for 10 ampere load. But for example, I have television and it's take 2 ampere. I have to put what? 3 ampere fuse. It will work for the same fuse, the 13 ampere fuse, but it will what? The television will be burned, that will make a fire, and the fuse won't even cut or melt. Why? Because the current here is too high, so the television, the fuse won't fill the television when it had some problems. The circuit breaker is what is instead of the fuse, and you can see it 9.4 figure. So this circuit breaker, it's a circuit inside that's made, there's not fuse, but there's a circuit that makes switch on and off, and there's wrong, it will sense that directly. And the earth, we say the electricity will go down. The double in solution, you find some kind of lamps. For example, radio, you don't have earth. So what if the heating elements or a wire is cutting and touch the body? Actually, it's made from plastic or rubber. Like for example, the land table is what you can see. This also the land table here, the red one. It's from plastic. That means insulated. So even if you touch it, you won't get electrical shock. So we call this double insulation. Go to RCD or residual cooling device. This device, for example, we have a fridge and we have electricity turned off, turned on, and the voltage is not stable. So we use this kind of circuits or this kind of devices what will protect our device, like the fridge or the television or etc. before any harm can done. So we said we have two kinds of plugs, the three. and the two. We explain the difference, and this will have fuse inside. Last thing we're gonna talk about is electrical hazard. So main electricity, of course, can be danger. What are the things that can be danger in the electricity? If the cable are old or fried wiring, broken strands mean that the wire will have a higher resistance, electron point. This means if we have an old cable or something in a device, what's happening will more resistance. More resistance, that means what? More thermal energy. More thermal energy, that means what? The device will be on fire and cause a fire in the house. So another example also, water in socket. So always if you are cleaning or you're doing something, please watch the socket. You have to turn off all the electricity, because if the water come into the socket, or the socket has any water, it will make a serious problem. Or long extensions, that means overheat, that also might cause a fire. And except in cables. So when you have something by coincidence and it's got cables, it will have, for example, here you're plugging and by a knife or a sharp thing, everything with it and cutting cables, it might touch each other and make a short. Okay, and that will cause a fire if there is no protection. So if you find someone getting electrical shock, for example, someone is with wet hands and holding the plug and they want to put the plug in. So if you find that they get electrical shock and for some reason, or there is no fuse, or there is no protection, or there is no earth, for any reason you saw this man is getting electrical shock, what you should do is not come and pull him back, because he will have electrical shock with him. As we know, the human body is conductor, right? So first thing you have to do is turn off the switch, or turn off the breakers or the circuits or whatever you find. You have to turn them off and turn off the plug. Then you help this man when you make sure there is no electricity above him or trying. So first thing, again, you turn off the electricity, you turn off the plug, then you help the man. If you touch him, the man or the woman, of course, if you touch them before, you have also electrical shock. That's it for the unit 8 electricity. Here we finished. So see you in the next unit, and take care, and don't forget to wear your mask.